Hi, welcome to the tutorial which talks about how we pass arrays to functions. The really super part about arrays is that when we create an array, C++ automatically gives us a pointer with the array, and it points to the first element in the array. Here's our phone bills array, float phone bills 12, and what C++ does behind the scenes, float star phone bills. Remember how we declare pointers? So this is actually a variable containing an address, and that is the address of the 0th element. Here's a picture of the same process. Here, this is our array with phone bills 0 through 11. And when we declare the array, then the phone bills at 0 is assigned into the name of the array. When we want to pass an array to a function, all we do is pass the name of the array. The name is a reference to the array's first element, or a pointer depending on how you want to call it, because pointers and references are both considered to be reference types. So we want to pass the address of the array to the function because we want the program to only have one copy of the array data. The arrays that we're using are pretty small, but in programming, imagine how big an array would be, you know, if you had all of the pixels on your screen. That's many thousands of items. Now, when you write a function that uses the array, you need to have the array data type and an array name, and then array operator brackets, so that the program knows it is an array. Otherwise, it'll think it's a variable. Here's a picture of this process. Here we are in main. Here's our float phone bills array, and we have a string month array, which has been initialized. We don't see that because we don't have the room to put it. And we are going to call this askBillData function. Well, let's look at the function. AskBillData string month, because it's a string array of 12 months, and float bills because it's a float array. Now notice the address of month is 0012 FE84, and the address of month in here is 00, I know this says 14, but that's a typo, 0012 FE84. The address of phone bills is 0012 FF44, and the address in the function is 0012 FF44. So we are really passing the address of the array. We use the array using whatever the local variables are here in the function. We see out the month and then allow the user to see in the amount of the bill for each month. And it's assigned. Here's the string. The bills will be assigned into the array, which will immediately be in the array in main. Three important things to notice. You always have to use the array data type with the array brackets, because otherwise it won't know it's an array. When you call a function and pass an array, you just use the array name. And the name of the array in the local function does not have to be the same as the name of the array in main. Okay, so let's show an example using arrays and functions. We're going to write a program that generates 100 random numbers, and we're going to store them in the array. We're going to use the bubble sort technique to arrange the arrays in numeric order to sort them. And the following figure indicates how that's going to happen. Here's int main. Here's our array, which contains 100 numbers. We want to generate random numbers and fill the array. So we're going to pass numbers, the name of the array, and total, the number of items in the array, because an array doesn't know how big it is. It doesn't have any functions like a vector does. So you have to pass the number of items in the array along with it. We're then going to take our array of 100 and pass it to the sort method with total so that it can be sorted. And then we're going to pass it to a show first last 5 method, which will, here's the numbers, and the total again is going to write the first and last 5 values of the array so we can see what they are. Briefly, let's talk about the bubble sort. It's a pretty simple sorting algorithm. And I don't know that it's painfully slow, but it's slow. It works by comparing adjacent values. What does that mean? It compares the value at 0 and the value at 1. If the value at 1 is larger, if the value at 0 is larger than the value at 1, it swaps them. The sort then compares and swaps if necessary for the next 2 values. So it basically continues one by one going through the array. The result of one pass has the largest value in the last element. You can see how that works. The sorter then starts out with the second value. It says here when using large amounts of data, avoid the bubble sort. Well, that's true. If you have more than, say 5,000 items, I would definitely not use the bubble sort. So here's the code for our bubble sort. We have 2 for loops. The first loop goes from 0 to total minus 1, and you'll see why. And the second one starts at 1 and goes to total. And this gives us items to compare. So let's see what happens. Okay, we start out by declaring I, j, and temp. Here are our variables. And these are the first 5 numbers in our array. Definitely not sorted. Okay, we start our for loop with I equals 0. Here it is. And then we start our second for loop, the nested for loop, with j equals 1. And we check. If the number at 0 is greater than the number at 1, we create a temporary, we assign the number at 1 into a temporary. Okay, that's both of those. And then we assign the number at 0 into the number at 1, and then the temporary into the number at 0. Whenever you do swapping in place, you always need to have a temporary to do the swapping. And look, here they got swapped. So let's try the next round, which is going to be when j equals 2. So we're going to compare 64 and 12. If the number at 2 is greater than the number at 1, which it is, we're going to assign the number at 2 into the temporary, which we did. We're going to swap the numbers. Here's the first assignment, there's the second assignment. There you go. And these 2 guys got swapped. So this is how far we got so far. we swap 35 and 64, and then we swap 2 and 64. Now, the result of this first go-around is that the largest number is at the end, and we go back and start again. We swap 12 and 34, 34 and 35 don't need to be swapped, and 2 and 35 do need to be swapped. Now the largest two numbers are at the end. Once again, we start. 12 and 34 are okay, 34 and 2 are not okay, and 34, 35, and 64 are the largest numbers. Finally, we check 12 and 2 and swap those, and look, we've now sorted our subarray of 5 items. This works just as well for 100. Okay, so here are our function prototypes for calling sort, generate random numbers, and first and last 5. Here's main, int numbers 100, total is 100, so that we have a number to send with total. We have a cout to identify what the values are. Here's generate random numbers. Remember how we did this? We seeded the random number generator with system time, and now we are getting random numbers between 0 and 32,767, from 0 to less than total, so that's going to be 0 to 99. Okay, we need to include time.h or actually ctime in order to be able to use the time function. Here's our bubble sort again. This is just like what we were looking at before. And here's our show first and last 5 function that takes the numbers and the total. And the only way, if you recall, that we can display all the items in an array is with a for loop. Because if you try to cout numbers, what are you going to get? Well, you'll get the address of numbers at 0. Not very interesting. So we've formatted our cout so that it looks like an array, and we're going to show the first 5 numbers, 0 to less than 5, and the last 5 numbers, total minus 5 to less than total. And here they are. The first 5 values, definitely unsorted, also the last 5, and here we have sorted all our values. So that's it for the tutorial on passing arrays to functions. It doesn't matter how you what you're going to do in the function. Just remember that the name of the array is the pointer to the first value. You can see that the next topic is character arrays, and that'll be the subject of another tutorial. If you have any questions about passing arrays to functions, feel free to email me, come to office hours, or ask a question on the discussion board. Bye now.